Today I'm going to go over Module 9.3, Solving Rational Equations. The essential question is, what methods are there for solving rational equations? And I'm actually going to go to page 454, which is the next page, and go over Explain 1 and talk about how to solve rational equations algebraically. So let's get started and go ahead and read through this. Rational equations can be solved algebraically by multiplying through by the LCD and solving the resulting polynomial equation. However, this eliminates information about the excluded values of the original equation. Sometimes an excluded value of the original equation is a solution of the polynomial equation, and in this case, the excluded values will be extraneous solution of the polynomial equation. Extraneous solutions are not solutions of an equation. So what this is basically saying is when you multiply by the LCD, you eliminate finding those excluded values, but those are still excluded values. So we have to take into consideration those. Those excluded values that end up being solutions at the end are extraneous solutions because we can't include those if they couldn't be solutions for the original equation. So let me show you what that looks like in example 1. So in example 1, our excluded values would be setting the denominators equal to 0, right? So I would have x minus 5 equals 0, and when I solve by adding 5 to both sides, I would get x equals 5. For my second denominator, I would have 2x minus 10, and when I solve that, add 10 and divide by 2, again I get x equals 5. So the excluded value here is going to be 5. We cannot have that as one of our solutions. If we do get that as one of our solutions, then that is called an extraneous solution. For identifying the LCD, we are going to look at our denominators, and we're going to have to factor them. So for our first one, we have x minus 5, which is already factored. And then what they did here for us was they showed that this second denominator on the right side of the equation can be factored as 2 times x minus 5. So the different factors that we have are 2 and x minus 5. So this is our LCD. And what we're going to do is we're going to multiply each term by the LCD. So here we are multiplying by it, and here we are multiplying by it. And what happens when we multiply by this is we actually have an x minus 5 on top and an x minus 5 on bottom that cancel. And then what do you think we're going to have to do with that 2 that's left? Well, hopefully your guess was to distribute, because we are going to have to distribute that. On the right side of the equation, there is a 2 on bottom and a 2 on top, so those will go ahead and cancel and reduce out. And an x minus 5 and an x minus 5. All right, so let's go ahead and scroll down just a little. And let's continue. So I said that we have to distribute this too, and when we do, we get 6x plus 14 equals 5x plus 17. And we want to go ahead and solve. So we're going to move all the x values. So let's subtract that 5x over. Move all these x values to one side, and that's how we get x. And then we want to move that constant, 14. Oops, sorry. Let's do that right here. Let's move that constant, 14 over. And we get that x equals 3. So the solution is x equals 3. And it was not one of our excluded values, so that is the actual solution of our equation. If we ended up getting a solution that was x equals 5 at the end, then we would actually not call that our solution, we would call that an extraneous solution. But in this case, we didn't get that, so, well, our solution, x equals 3, is our solution. So I'm going to flip to the next page, and we're going to do part B, and so that's on page, 455, and let's look at part B. So again, we want to find those excluded values and set our denominators equal to 0, And we have x minus 7 here and x minus 7 here. So we don't need to write that twice. And we don't need to set 2 equal to 0 because that doesn't make sense, right? So we're going to set this denominator, x minus 7 equals 0, and solve. So add 7 to both sides, and so I get x equals 7. So the excluded value is going to be x equals 7. Now for our next part, I'm going to go ahead and underline that so we know that that was the step 1. Step 2 here was identify the LCD. And so our different factors of our denominators, we have x minus 7, we have a 2, and then we already have an x minus 7, so we don't have to repeat that. So our LCD is 2 times x minus 7. And so that is what we're going to multiply each term by. And notice that in this one, this original equation up here, there's 3 terms. There's this plus this equals this. So when we multiply by our LCD that we just found, we're going to multiply each of those by it. So we're going to multiply by 2x minus 7, 2x minus 7, and 2 times x minus 7. And let's see what we can cancel out here. Oh, it looks like they want us to fill in these blanks twice. Let's see. So if we fill these in, now we can go ahead and eliminate what we have here. So this x minus 7 and this x minus 7 will eliminate. This 2 and this 2 will eliminate. And this x minus 7 and this x minus 7 will eliminate. So what's left is we have to multiply by this 2 here to the 2x minus 9. What's left here is this x times the x minus 7 that's left. And here we have 5 times 2. So I'm going to go ahead and distribute this. So 4x minus 18. Distributing this, I get x squared minus 7x, which they filled in here for us. And we get 10. So we're going to move everything to one side so that we can go ahead and factor this. So I'm going to subtract this 10. Right, and I wrote it underneath the 18 because the 18 is a constant and the 10 is a constant, so I can combine those. And I'm going to get, let's see, x squared, and a 4x and a negative 7x gave me a negative 3x. And that 18 and negative 10 gave me a negative 28. So now that it's in standard form and we have a 0 over here, we can go ahead and factor. And we're going to factor in order to solve this. So x times x is what multiplies to x squared. What multiplies to 28? I could use 1 and 28. What is that? 2 and 14. 3, I believe, doesn't go into it. So let's try 4 and 7, 5, 6. Those don't go into it. So keep in mind what you're trying to add to. I'm trying to add to 3 here. So I'm going to use the 4 and the 7 because a positive 4 and a negative 7 will add to a negative 3. And that positive 4 times that negative 7 will still give me my negative 28 that I need. So the two factors we got were x minus 7, which we have here, and x plus 4. And we're going to solve each of these in order to get x. So it already solved this one by adding 7, so let's subtract 4 here, and we get a negative 4. Now let's go back to the beginning where we found what solution was extraneous. Let's go to the top. Excluded. So we found that the value x equals 7 would be extraneous. So right here, the value x equals 7 is extraneous because it's an excluded value. So the only solution for this one is x equals negative 4. Okay, so just to point out, what that means is we got two answers here, but we have to go back to the beginning where we said, hey, what values would be excluded? And that x equals 7, well, this one would have to be excluded. And so x equals 7 is an extraneous solution, and the only solution that we have for this one is x equals -4. So the your turn here, I'll go ahead and get it started for us just to remember some of our steps. Step 1, we said, was to find those excluded values. So take our denominators, x plus 3 and set it equal to 0, and x plus 6 and set it equal to 0. So our excluded values are going to be a -3 and a -6. Step 2 was to find the LCD. So the LCD is going to be all the factors of our denominators. And so we have an x plus 3 on that left-hand side and an x plus 6 on the other side. And so that's our LCD. Now, the third thing that we do is we multiply each term by the LCD. And so I'm going to write my equation. I have 8 over x plus 3 equals x plus 1 over x plus 6. And I'm going to take this LCD that we have, and I'm going to write it to where I'm multiplying each of these by it. So x plus 3, x plus 6. And then we simplify. So we have an x plus 3 on bottom and an x plus 3 on top, so those can eliminate and cancel out. Here I have an x plus 6 on bottom and an x plus 6 on top, so those will go ahead and cancel. And if I rewrite this just to be clear, I have an 8 times the x plus 6 left, and on this other side I have an x plus 1 times an x plus 3. So let's go ahead and solve now. So step 4 is going to be to solve, and I'm going to do that by distributing. So 8x plus 48. Distribute these, that's x squared plus 3x plus 1x plus 3. And remember, we're going to move everything to one side. So I can combine these first. And I'm going to subtract that 48 at the same time. So 8x equals x squared plus 4x, because that 3x and 1x gave me 4x. And I get a -45. And now I need to subtract 8x. So I have 0 equals x squared minus 4x minus 45. So now that I'm in standard form, remember we can factor this to solve. So what multiplies to x squared is x and x. What multiplies to 45 but adds to 4 is 9 and 5. And I need the 4 to be a negative 4x. So the 9 has to be negative and the 5 has to be positive. And now I set each of these equal to 0. So I get x minus 9 equals 0, which gives me x equals 9. And I get x plus 5 equals 0, so x equals -5. Now, neither of these, remember, were excluded values up here, so my solution is both of these. So a quick recap, how do we solve rational expressions or rational equations algebraically? We identify our excluded values, we find our LCD, we multiply by our LCD, and then we solve. Make sure you check to see if any of these are supposed to be excluded values. Good luck!